All right, 8th graders, hello, it's Mrs. Johnson. We've talked so much about slope, and you might be feeling overwhelmed by all the slope stuff that is in your notes right now. So we are going to pull up page 29, and we're gonna wrap everything up into one nice, beautiful slope-shaped package. So let me share my screen with you. And let's talk about slope. In fact, we're gonna talk about all things slope. Again, this is on page 29 in your math binder. So open your math binder, pull out page 29, grab a pencil. How do you find the slope? Well, there are 3 different situations where you find a slope, and those happen to be the 3 situations that we are going to see on our next test. So let's talk about in a graph. What do you do? Where's my blue marker? Found it. Okay, what do you do in a graph to find the slope? First thing that you always want to do is draw your corner dots. You always need 2 corner dots that are at beautiful, lovely little corners there, and then you can find your slope. So we always write down m equals, and it's always going to be a fraction. The numerator of our fraction is the rise, and the denominator is what we call the run. So what does that mean? Well, the rise is going to be how far up or down your graph goes. So if it goes up, it's a positive in the numerator. If it goes down, it's a negative in the numerator. Okay, then the run is telling you how far to the right or left that the graph goes. To the right, am I pointing to the right? That's right for me. To the right would be positive, to the left would be negative. Okay, so there are these things, and I will even write that out. Up is a positive number, down is a negative, right is positive, and left negative. I feel like that's a lot of blue. I should have definitely changed the colors in there. So I'm going to separate this with pink and just remind you that it applies to the stuff up above. Okay, so how do we do this when we have ordered pairs? Well, when you have ordered pairs, I always give you the ordered pairs as a pair. So we say that the first one, we always label it, if you remember, x1, comma, y1, because it's the first ordered pair. And the second one would be x2, comma, y2. Okay, there's our 2 ordered pairs. Now that formula, which is a very important formula, you should memorize it forever and ever and ever. You could even like get it tattooed across your forehead, but you shouldn't do that because I'm gonna give you my talk now. Tattoos are great, but you should not get a tattoo until you're 25. Here's a reason why. I know that you legally can at like 18 or whatever, but when you were 25, you stop making such poor choices in your life because people who get tattoos way before 25, usually later in life are like, wow, I really regret that because I got like the Statue of Liberty tattooed on my ankle, which is kind of a weird tattoo. So we should definitely still not get that tattooed on our forehead, but if you are going to get a tattoo later in life, remember, your math teacher said, wait till you're 25, because there is a good chance that you will regret it and want to get rid of it if it's something that you choose when you're 18 or 19 or 20 or until 25. Don't ask me why, I just know that you are far more mature at 25. Yes, you can quote me on that. Okay, anyway, let's stop talking about tattoos and we'll start talking about slope. Okay, we've got our slope formula, which you can like tattoo on the inside of your eyeballs. I don't know, just never forget this formula. It is y2 minus y1, and in the denominator, x2 minus x1. I'm not joking that you want to remember that in the heart of your soul for the rest of your life, because that formula is going nowhere. And if you are the kind of person who is going to have math be a part of your future in college because you want to be an engineer or a doctor or a lawyer or a statistician or an accountant or whatever, you are going to need to know slope. Okay? All right, now let's talk about a table. Now with the table, I know I always say this annoying thing, but I'm gonna say it again. The first thing you do on a table is you are going to draw swoops. Miss Johnson, what the heck is a swoop? I'll remind you in a second. And then once you have your swoops, you can then say that m equals, and in the numerator, it's going to be change in y. In the denominator, it's going to be change in x. change in y divided by change in x. Okay, let's put these 3 scenarios into practice. And I'm going to start with the tables. Now it says draw swoops. Okay, let me remind you what swoops are. You are going to draw a swoop from the first item to the second. How do I go from 5 to 6 with addition? Well, right there, 5, and I have to plus 1 to get 6. So my swoop is telling me to add 1. Oh, that's a swoop. Okay, from 6 to 7, I have to add 1. From 7 to 8, I have to add 1. So I'm adding 1, adding 1, adding 1. That's my change in y. So let's check this change in x. From 2 to 4, how do I add to get from 2 to 4? Well, I'm adding 2. There's my swoop for my change in x. From 4 to 6, I'm adding 2. And from 6 to 8, I'm adding 2. All right, so my change in x was adding 2. My change in y was adding 1. So let's write that as my slope. Remember, change in y goes in the numerator, change in x goes in the denominator. So m equals, and my change in y over here, I can choose any one of these 3. I'll start with the first one. It's a 1, or positive 1, and then straight across from it, I have a 2, positive 2, 1/2. Now, could I have chosen different ones? Yeah, this would be 1/2, this would be 1/2. Sometimes it's like 2/4. That's okay, because 2/4 would reduce to 1/2. So don't freak out if your change changes, because hopefully it will change by the same proportion on the other side of the table for your change in x. And we might see one of those examples. I can't remember because it's been a while since I've done this paper. All right, let's look at number 2. Start by drawing in your swoops. I'm going to pause the screen, and you are going to pause your screen, and you're going to draw in your swoops. And I'd like you to actually try problems 2 and 3. Pause the screen. Don't be a cheater. Okay, you paused your screen, and you gave yourself a chance to find the swoops and to find the slope, and I'm going to fill it in. You're going to watch what I do, and if there's anything that's done wrong on your paper, you're going to pick up your pencil and not so shamefully erase and fix whatever you messed up on. So to go from 3 to 0, oh my gosh, how do I go from 3 to 0 with adding? Well, that's actually subtracting, which could be adding a negative number. So from 3 to 0, I'm subtracting 3. There's my change, down 3 spaces. And then from 0 to -3, I'm going down 3 again, subtract 3. And from -3 to 6, I'm subtracting 3. There's my change in y. So if I were to start writing my slope, my change in y for the numerator is -3. Let's find our change in x for the denominator. -2 has to go up to get to 0. It goes up 2 spaces, so adding 2. From 0 to 2, I'm adding 2. And from 2 to 4, I'm adding 2. So I was always adding 2 there for my change in x. So again, if I chose that -3, I'm going to choose the -2 directly across from it. But again, I could have chosen these 2. You just have to make sure that the changes are the ones directly across from each other. So -3 over a +2, and that's as reduced as it gets. Now, if it wasn't reduced, I could reduce the fraction clearly. And again, we typically try to put the negatives in the numerator. That's how you're going to be typing them in to your Canvas assignments as well. The negatives will stick in the numerator. Okay, one more problem. Let's look at number 3. You already did this one on your paper. From 8 to 6, I'm subtracting 2. From 6 to 4, subtracting 2. From 4 to 2, subtracting 2. There are my swoops for the y values. For the x values, from -5 to -1, I'm adding 4. And from -1 to 3, I'm adding 4. And from 3 to 7, I'm adding 4. So when I do change in y over change in x, I just choose 2 that are across from each other. M equals, and a common mistake would be putting 4 over -2. I don't want x over y. I want the change in y over the change in x. So I'm going to put -2 over +4. 8th graders, if you left this for your answer, I would mark it so wrong because that's not reduced. -2/4. That's divisible by 2 in the numerator and the denominator. So divide it and it becomes -1/2. Okay, that's our final reduced form, and you've got m equals -1/2. All right, that is a table. We see lots of lovely examples of a table in this paper. on this paper. Yeah. Okay, let's go to the graphs next. 5, 6, and 7. Draw your corner dots. Find your rise over run. If you're going up, it's positive, down is negative, and right is positive, left is negative. Okay, so I'm going to start on number 5, and I'm going to draw in 2 really good corner dots. I'm going to use the color red. Okay, this is a good corner dot. Bad, 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 good. Bad, 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 good. There's like a pattern. And also I'm like annoying myself. It's so fun. Okay, and there's one more good one. I actually have 4 corner dots that I can draw in. You only need 2 of them. So once you have your 2 corner dots, then you can find the rise over run. I'm just going to use the first 2 dots. So if I'm using these first 2 dots, I am going to go up or down first. I'm not going to the right because that's not a rise or a run. Or excuse me, that's not the rise. So I'm going to actually go down. This is a negative slope, so I'm going down spaces. How far down did I go? Well, down 1, 2, 3. That's a -3 for my rise. Then I go to the right 2 spaces, which is a +2 for my run. My slope, m equals -3 halves. That can't be reduced because it's as low as that fraction goes. I want you to draw in nice corner dots and find the rise over run reduced for problems 6 and 7. Go. Pause the video. All right, on number 6, I'm gonna draw in 2 good corner dots. If I were to start here, and let's say that I'm gonna go to, I don't know, maybe I'll go up there. There's a lot of really good corner dots, but I wanna make an example of this one. This is going up 1, 2, 3, 4 spaces. That's a +4 because it went up 4 spaces. Then from there, it goes to the right 1, 2, 3, 4. Now, when I do that, it's m equals 4 for my rise, 4 for my run. And when I reduce that, I get 1. Well, what does that 1 mean? I want to remind you that we could have chosen a lot of other dots. This is telling us that if I start here, I go, and I can make this 1 over 1, it goes up 1 to the right 1, 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 up 1 to the right 1. That's my slope, up 1 to the right 1. Technically, up 4 to the right 4 would also work, but up 1 to the right 1 is the most simplified version that could get me all the way up this stair stepping. So that's what this slope means. Now, of course, that is equal to 1, but I do want you to know that there's always a hidden 1 underneath, which is why you type it into a lot of your answers on your homework today or tomorrow. I can't remember which day it is. Okay, number 7, let's see if you tried this one correctly. I'm going to choose 2 nice looking dots. And on this one, I am going to start by going down 2 spaces, and then this one goes to the right 4 spaces. Notice I put arrows on it to help me see which directions it was going. M equals -2 for my numerator, +4 for my denominator, and I get -1/2. Now, also, if you had chosen to go up 2 to the left 4, that'd be fine because it would still be a +2 now, but when you go to the left 4, that's a -4. And that would still reduce to -1/2. So regardless of which way you chose to do this, you would still get a -1/2. All right, now these are the ones that sometimes people struggle for problems 8, 9, and 10, because sometimes they don't use the formula correctly, or they just think, oh, this is more difficult. It's not, I assure you, you are just filling things in to a formula. So I'm gonna start by labeling x1, y1, x2, y2. So looking at problem number 8, I will start by saying -4 is my x1, so I write an x1 beneath it. 7 is my y1. The reason that those are x1 and y1 is because they are the first coordinate that was given to me. -4, -12 is the second coordinate, so it's going to be x2, y2. Okay, now I go back to that formula that we have for slope. y2 minus y1 over x2 minus x1. Remember, it's tattooed on the inside of your soul. Okay, so I'm going to write m equals fraction bar y2 minus y1 over x2 minus x1. Okay, now I can actually plug in my x1, y1, x2, y2 stuff. So under here, m equals, I've got my fraction bar, but what was y2? Well, y2 is directly beneath negative 12. So I've got negative 12 first. Then remember, there's a minus. So put your minus. And then my y1 is 7. I'm taking that directly from the ordered pairs. In the denominator, x2 is negative 4. So I'm going to write that down, negative 4. You have to put a minus sign. And then this next negative 4, which is x1, is going to go in parentheses because we don't want to forget that it's subtracting a negative. All right, let's do the math on this thing. Negative 12 minus 7. And I get negative 19. Okay, negative 4 minus negative 4. And I get 0. My denominator is 0. Okay, now let's reduce that fraction. Some of you might be saying, oh yeah, it's 0. Let's double check. Negative 19 divide by 0. Not 0, it's error. What does it mean when we get an error? What does it mean when 0 is in the denominator? It is undefined. Maybe I shouldn't do an exclamation. I should say like, oh, that's sad. That's a very undefined answer. Okay, 8th graders, now's the part of the math problem where you push pause and you actually try numbers 9 and 10. So be an honest, beautiful 8th grader, push pause, and I will explain these when you are done. Okay, hopefully you were honest there, because that would be the best kind of practice that you can get, is using your honesty and actually trying these on your own, because then I go over them with you. I just colored on myself. Okay, problem number 9. Let's label this x1, y1, x2, y2. Then I'm going to write down my formula. I actually already have it over here, so I'm just going to plug the things into my formula. M equals fraction bar, and y2 is negative 13. Always put a minus after it. Y1 is negative 9. In the denominator, x2 is 4. Always put a minus sign. And x1 is negative 4. Don't forget your parentheses. I wish I could like cry that at you, but sometimes I can't cry on demand. Sometimes I can, which is a pretty cool personality trait. Okay, so let's type this in. Negative 13 minus, and then you could say oh gosh, there's like other stuff on my calculator. What a weirdo. Negative 13 minus parenthesis, negative 9. And you can type in parentheses on the Desmos calculator as well. And I get negative 4 for my numerator. In the denominator, 4 minus negative 4, and I get 8. Okay, negative 4/8. That's a pretty easy fraction to reduce because both the top and the bottom are divisible by 4. Negative 4 divided by 4 gives me negative 1, and 8 divided by 4 is 2. So M equals negative 1/2. Woohoo! All right, let's go to number 10, which you have already done because you're such an honest 8th grader. X1, Y1, we always start there. X2, Y2, we always go there next. All right, I'm gonna use the formula that I've got, M equals, I'm gonna draw my big fraction bar, and I'll start with Y2, which is 8, minus Y1, which is 11. In the denominator, I'm going to put X2 minus X1, so 4 minus 10. Okay, 8 minus 11. 8 minus 11 gives me negative 3 in my numerator. And 4 minus 10 gives me negative 6 in my denominator. Negative 3 over negative 6. Those are both divisible by negative 3 technically. Remember, when we have a negative over a negative, they would divide out and give you 2 positives. So this is going to be a positive answer, and 3/6 is actually 1/2 because they're both divisible by 3. So M equals 1/2. All right, I hope you feel like you got a little bit of practice on finding the slope in a table, finding the slope in a graph, and finding the slope when given 2 ordered pairs. When you do your matching on this stuff, which may or may not happen, or maybe that was yesterday, hold on. You always want to make sure that you refer back to these things. All right, good luck, my lovely 8th graders.